Welcome back to Study 101 Uganda. We are going to look at the electric bell and how it works. Our chart is showing the major components of the electric bell. We have got the switch, we have got the electromagnet, our power source is there, the dry cells, we have a soft iron bar, it has got a contact screw and a hammer. We are in the corona times, we are not able to access the real bell at school. We are going to be using this one on the chart. So, how does this bell produce sound? We are going to go through 4 steps. When the switch is pressed, the circuit becomes complete and the electromagnet becomes magnetized. That is our first step. When you press the switch, current runs through, the circuit becomes complete, and this is our electromagnet. It becomes magnetized. So when it becomes magnetized, we go to step 2. When it becomes magnetized, it attracts the soft iron bar. This is our soft iron bar. It is attracted by the magnet. When the soft iron bar is attracted by the magnet, the hammer that is attached to the soft iron bar then strikes the gong. It hits the gong, producing sound. Step 3, the hammer that is attached to the soft iron bar hits the gong. That is because the electromagnet was able to attract the soft iron bar. And then step 4, the soft iron bar goes with the steel spring. When it is attracted, there's a steel spring here. There's a steel spring here. Steel spring. So, when the soft iron bar is attracted and it goes onto the soft iron bar, it has a steel spring which is attached to a contact screw. So, it so happens that it loses contact with the contact screw. When contact with the contact screw is lost, the circuit gets broken. When the circuit is broken, our electromagnet becomes demagnetized. So we are going to run through these steps one more time. When the switch is pressed, the circuit becomes complete and the electromagnet becomes magnetized. This is our electromagnet. When it becomes magnetized, it attracts the soft iron bar, and on the soft iron bar we have got a part which is called the hammer. So the hammer will then strike the gong. So, but as it strikes the gong, because this was attracted this way, the steel spring loses contact with the contact screw, and then the circuit is broken. When the circuit is broken, the electromagnet becomes demagnetized. So when it becomes demagnetized, it loses its magnetism and then it releases the soft iron bar. When the soft iron bar is released, it gets contact with the contact screw once again, and the circuit is repeatedly, hence producing that sound. And all that happens so fast. So that is how the electric bell works. There are some questions that you need to be able to answer. And the first one is, which part of the electric bell produces sound? And that part is the gong. Question 2, what happens to the electromagnet when the switch is pressed? When we press the switch, what happens to the electromagnet here? And the response is, it becomes magnetized. It becomes magnetized. Then question 3, what happens to the electromagnet when the circuit is opened? What if we break the circuit? What happens to the electromagnet? The magnet will become demagnetized. It will lose its magnetism. Another question is, identify the energy changes. Identify the energy change that takes place when the bell. Identify the energy change that takes place in the bell. That is electric energy to sound energy. We give it electricity, it produces sound energy. Finally, there's another common question that is usually asked. Identify ways in which electromagnets are used in your school. And the commonest response we would give is the electromagnet is used in the electric bell. In case they say apart from using it in the electric bell, how else is the electromagnet used in your school? Maybe we would say it is used in the loudspeaker. Thank you for watching this video.